Hello and welcome to this presentation by the Royal Blind Learning Hub. My name is Anna Crystal and I'm both a qualified teacher of science and a qualified teacher of the visually impaired. I'm going to be talking to you today about issues and strategies for teaching and learning science. Now I'm hoping that given I've worked in both mainstream schools and in special schools, that I can bring my experiences together and give you some tips today about how you can best support the visually impaired learner in the science classroom. Now, obviously, as a science teacher, I am going to be very keen on teaching science, and I feel it's a very important subject in the curriculum. I think for a visually impaired learner, it has real benefits. If you can remember back to your own science classroom, you'll remember doing lots of experiments. You'll remember working collaboratively with your peers. Science is all about trying to sort of get you to explore real objects, real processes, and really sort of stimulating curiosity. And I think through that, what we're really trying to do in science is get this good understanding, a real understanding of how the world works. And that's got to be beneficial for all learners, but particularly our visually impaired learners. But what are the main issues? Well, on the slide here, I've addressed two main issues. I'm going to talk about the first, concept development, to start off with. And to help you understand what I mean by that, I've put a little picture of a house at the bottom of the screen. Now, as a sighted learner, I recognise very quickly that that is a house. But I need to think about why it is that I'm recognising that. In growing up, I've learned very quickly to relate drawings to objects. I can generalise very easily from a wide experience of seeing houses and seeing pictures of houses. But for a visually impaired learner, that can be very different. How are they going to know the shape of the roof, or the shape of the windows, or the relationship between the door and the chimney, unless that's explicitly described? It's very important that we're aware of how much our own learning as a sighted learner is constantly reinforced by what we see around us, be it colours, shapes, facial expressions, illustrations, objects. It's constantly reinforced. Children, young people with a visual impairment have much reduced opportunities for this incidental learning and reinforcement of their learning. So this means that it can present challenges in science when we're doing things like classification, that it can be difficult for a visually impaired learner to recognise the similarities between different bird species, or the difference between birds and bats. Generalisation, sort of recognising that dogs come in all sorts of shapes and sizes, from small Chihuahua up to the Great Dane. This can be all quite challenging. We use a lot of diagrams in science teaching, and sort of relating these 2D flat drawings to the actual objects or what they represent can be quite challenging as well. So when we're teaching in science, we need to really reinforce, we need to use a lot of very explicit language, lots of opportunities to look at variety and differences, to sort of try and strengthen the visually impaired learner's understanding of concepts. The second issue, which I'm going to talk about later on in this presentation, is really the adaptations that we need to make to the curriculum and to the practical work that we're doing in the science classroom. So I'm going to go back to this idea of concepts, and I think, as I sort of talked about at the very start of this presentation, science is about doing practical work, and this is where you have so many opportunities for really reinforcing their learning. If you're handling specimens and models, if you're stretching materials, pulling, pushing, weighing, pouring, moving, measuring, this is all about touching, feeling, exploring, reinforcing your learning. So I think there are lots of really good things that you can do in the science classroom that just come about through the sense that it is a practical subject. And when we're coming to the curriculum and accessing the curriculum, we've got to go through these points in turn: concrete materials, models, diagrams, written materials, procedures, and equipment. Okay, so this is really just sort of highlighting what I'm going to go through in the talk. So as I've already said, concrete materials are really useful for sort of addressing some of the difficulties with concept development. And wherever possible, it's really important we try and get the real specimen, the real object or material there in the classroom for the visually impaired young person to explore. So on the slide here, you can see if I'm teaching about flowers, I want to have a real flower, and something like a lily is a really good big flower to pull apart and explore all the detail within the flower. If I'm teaching about the heart, it's really good to visit your local butcher and get a sheep's heart. You can then hold it in your hands. You can get the weight and the size of the heart. It's very similar to a human heart. You can sort of explore the various arteries and veins and get a real sense of what that organ feels like. Obviously, not always can you bring objects to the classroom, so it's good if you can get out there and visit places, like visiting an airfield if you were talking about aeroplanes, if you're going to talk about farming and combine harvesters. It's good to get out there and visit places and give the visually impaired learner the opportunity to touch and get an idea of the size and scale of some of these bits of machinery. Borrowing is good as well. We can get out there and link up with our local museum or link up with our local college or university. Whenever we've got these objects or specimens, what we want to do is to get our visually impaired learner to explore it as much as possible, to really get them to get an understanding of how this object works. And to do that, it's really important that we're using two-handed exploration. It's only by using two hands that you can relate the parts of the object to each other. It's only by using two hands that you can really get a sense of scale to that object. If you have somebody who's a little tactile defensive, you can encourage that exploration using hand over hand. And what I mean by that is that you would use your hand to guide the visually impaired learner's hand. We'll just pull that into screen so their hand is on top of your hand towards the object, and you would then be helping them to explore the object in more detail. If for some reason they're reluctant to touch, they're then obviously free to remove their hand very easily. So hand over hand, your hand guides the visually impaired learner's hand towards the object and helps them explore that. Now, obviously, we can't always use real specimens. So up on the screen here, I've got a selection of different models that you might be able to use. There are many, many more out there. If we break those down, we've obviously got commercial models. So we've got on the screen there a picture of a torso, typical bit of kit in most sort of school science laboratories. Very useful for teaching all about the various organs and their location. But obviously it's made of plastic, so it doesn't feel like the real thing. But it's giving a sense of how these different organs connect and fit in together. Down in the bottom right of the screen, I'll try and get this the right way around, we've got a section through a leaf. So this is a model showing what it's like from the top to the bottom of the leaf. Very useful because that's something that can only really be seen through a microscope, so that this is giving a more three-dimensional exploration of the various cells within that, which is very useful to the visually impaired learner. Homemade models are very useful. On the screen in the middle there, we've got pictures of some chromosomes, which I've made out of things called wiki sticks. Now, wiki sticks are waxed strings. They come in lots of different colours, and you can cut them to size, and you can bend them and they can kind of keep their shape, stick to the paper. They're very useful for making little sort of instant models in the classroom. So in this particular model, you can see that I've cut some wiki sticks to lengths, and I've joined them together with a little bit of blue tack to represent chromosomes. The great thing with this model is that you can then move things around, and you can sort of represent things that are happening in cell division, and sort of almost recreate a sort of animation that perhaps the visually impaired learner's sighted peers would be using to explore the process of cell division and chromosome movements within that. In the middle of the screen as well, we've got a picture of some little chemical jigsaws. These are put together to use to demonstrate DNA replication. So it's again another sort of moving working model that we can make very quickly in the classroom to sort of illustrate the structure of DNA in this particular instance. I think it's really good to get pupils involved in actually making models. So the final picture there, the one with the plastic bag, is representing a cell. And this is an exercise I really like doing in class. It's very challenging for a lot of visually impaired learners to sort of use things like microscopes successfully and to look at cells. So this gives them a real sort of understanding of what the various parts of a cell are. So here we've got a very simple model of an animal cell made out of a Ziploc bag, the thin plastic bag representing the cell membrane. Into that we've poured lots of nice yellow jelly representing the cytoplasm within the cell, and then we put a little table tennis ball in there to represent the nucleus. And that's a really nice little exercise to give a sense of the sort of three-dimensional nature of cells, which can't be represented on a 2D diagram. But diagrams are needed increasingly as your visually impaired learner goes through school and moves towards examinations. They will be required in many of their examinations to use diagrams. So I hope by this point we're beginning to sort of see the importance of starting with real concrete objects. I think that is key to how you approach the teaching of things like the heart or the lungs, that we start with a three-dimensional object. We can then start to try and relate that to the diagram. But I think what I would start by saying at the top of the screen there is that I think you always need to sort of be just questioning whether or not this is a diagram that realistically your visually impaired learner needs to know or needs to have an understanding of. Often in textbooks, diagrams are put in there to sort of break up the text and make it look more interesting. For a visually impaired learner, working their way around a diagram, especially a diagram if it's been poorly adapted, can take an inordinate length of time, and the benefit from that is not always very clear. So if we're thinking about diagrams, let's break it down a little bit. What sort of diagrams could we be talking about? So we could be talking about things like the heart diagram that we've got on the screen here. Diagram representing an object. And that is obviously a useful diagram to help take away and learn about heart structure. I don't think there's too much of a way around that, particularly if you are moving on to look at examinations. However, I think it is important at this point to just think about where you're getting that diagram from. And if it is linking to examinations, it's probably good to link with your exam board and try and find out what the sort of standard diagram they would use for their adapted examinations would be. Other diagrams might be diagrams commonly used like setting up an experiment. Now, in that instance, it can often be very complicated, and for a severely visually impaired learner, it would be often more beneficial to either set up the experiment using the actual bits of equipment or to explain how the experiment was set up. Complicated diagrams of exam setup or experimental setup can be very difficult to access. So presenting that in another format is often good. The final sort of diagrams are obviously the sort of graphical representations of data. That is obviously going to be an important skill to develop, so we'll talk about that more in a little bit later in the presentation. The key thing, though, that if you're going to have a diagram, and I've kind of emphasised it on the screen here several times, is that it needs to be simplified. You can't just take an existing diagram, enlarge it, or go round it in black pen. It's not going to work. You really need to strip out all the extraneous sort of detail to sort of focus on what is really, really needed. So simplification is really key to making sure that the diagrams are accessible. I've just put up on this slide a good source of information. If you're looking for diagrams in the UK, this is a great website to link with. Load to Learn has lots of diagrams developed by teachers of the visually impaired and the RNIB that are readily accessible. So rather than doing your own diagram, making up your own diagram, or if the exam board hasn't got a specific diagram that you want, this is a good resource to use. Now, other forms of adaptation, if you're thinking about what you need in the science classroom, we're obviously thinking about the written materials that you'd be wanting your visually impaired learner to sort of be accessing descriptions of the experiment, or sort of descriptions of the process that we're looking at. Things to just be aware of, and I'm just going to touch on this very briefly, just common sort of issues. If you're working in large print, we want to be a little bit aware of things like line thicknesses. So if you're drawing a graph, just to make sure that the line thickness approximates the sort of width of the text that they're using. And you can see on the screen there, sort of subscripts and superscripts are often smaller in size and might not be accessible. If you're using Braille, down at the bottom of the screen there, you want to be using the current Braille science code. You're probably well aware that we're in the process of moving from standard English Braille to Unified English Braille, so you need to make sure that you're up to date and using the current science code for Braille. There should be some references at the end of this presentation for that. The final option is that in both reading Braille and in reading large print, it can take longer than it would do for a print, a normal print user. So using sort of audio can be very useful for providing sort of summary notes or homework so that they can listen to that, and that can often be a good way of getting information across. So we're now on to the final sort of section of the presentation, and this is really about how we can get our visually impaired learner fully included in all the practical experimental work in the science classroom. And I'm going to go through this list. There's a whole range of different things here, and just try and give you a little bit more detail on that. So up at the top of the screen there, I've put down that you can add food colouring to maximise contrast. Now obviously for a partially sighted learner, that's going to help them to see sort of clear solutions. If it's got a little bit of food colouring, it often doesn't make any difference to the experiment. It's just going to maximise the contrast. It can also be useful to a blind learner as well, because it can enable them to detect levels using sort of audible light sensors. But I'll talk about that in a little bit later. When we're doing sort of experiments that involve chemicals, what we're wanting to do is we're often wanting to maximise the fizz, the smell, the sort of sound of the experiment, and that to do that it's often possible by sort of looking at changing the volumes or concentrations of the reactants to make the experiment a little bit more dramatic or more obvious for the visually impaired learner. And science teachers are normally very happy to look at that and see what they can do. Measuring volumes given off, for example, in an experiment where we've got a gas evolving, can be a little bit challenging. You might want to measure mass, can be easier to measure using a sort of talking balance. So that's a suggestion that sometimes mass is easier to measure than volume. And if you're doing stuff like electrical circuits, and looking for continuity in that electrical circuit. Replacing a bulb with a buzzer is a very sort of quick solution to make that more accessible. So we're here looking now at adapted equipment. One of the things I've put up there at the top is that it's very useful for the visually impaired learner to have a defined work area. And we can do that using sort of spill trays. A spill tray is a tray with a very sort of low edge to it, designed to sort of catch any sort of accidental spillages, but it also is very handy for helping the visually impaired learner locate equipment and just sort of work within a sort of a known area. I've put up there that you can use Tactimark to mark beakers and measuring cylinders. Now I've got a little bottle of Tactimark here, which I'm going to just hold up. Try and get that into the screen, I always pass it the wrong way. So this is Tactimark. You can see it's a very brightly coloured liquid. You can apply that to glassware and it dries hard and it creates a sort of tactile ridge. So it's very useful for marking the sort of the volume on the beaker to make it easier to sort of identify. Okay, so that's Tactimark. We can use brightly coloured paint for tripod legs or for clamp stands, retort stands. That just makes it a little bit safer in the classroom, that it's easier to locate those for our partially sighted learner. I've mentioned there notched plastic syringes or autopipettes. I've not got an autopipette with me today, but I have brought along a couple of syringes. If I hold this one up here, okay, you can see it's marked with the Tactimark. Okay, this is a very large syringe. You get them in all sorts of different sizes. Let's bring a slightly smaller one. Okay, this one might be a little bit clearer to see. Okay, again with the Tactimark. Now what you do with notching is that if I pull the plunger up, okay, along the edge here, we've got notches that correspond to different volumes. So what that means is that the visually impaired learner can put their syringe into the liquid they're wanting to measure a volume of, and they pull up the plunger and they're feeling for notches that are level with the end of the syringe. Okay, so for example, this is the third notch on the plunger, which the visually impaired learner can learn then is your 15 milliliter measurement. So notch syringes. You can just do that with a sort of like a Stanley knife. Just cut out some notches that are easy to identify with a finger. Okay, I've already mentioned the audible light probe. This is a really useful device, particularly if you're thinking about experiments with rays and trying to identify where rays are reflected to. I've got one example here. Okay, so what this does, if I hold it up, okay, if I point it to the ceiling, you're getting one pitch. If I point it to the bench, you can hear that, you get a much lower tone. And so this can be used to identify where a ray or light beam is. It can also be very useful if you're using a little bit of food colouring to identify where the volume of a liquid in a measuring cylinder, or the increasing volume of something like a yeast dough. Various things you can use that for with a little bit of experimentation and imagination, okay, because it just varies in tone according to how much light is reflected. You can get talking colour indicators. So if you're doing experiments where there's a colour change, there are sort of proprietary colour indicator devices, but increasingly with things like apps, you can get colour apps that will speak. You can point them at a particular test tube or beaker and it will tell you the colour of the solution or the colour of the object, and that can be very handy and increasingly sort of accessible. Mentioned already talking balances. You tend to get sort of balances that are designed for sort of home economics, which are kind of obviously good for sort of very large scale differences in measurements of mass. if you're wanting more precise measurements, you're often wanting to use a USB connection with a sort of scientific balance. And if you've got a screen reader or some sort of magnification software, that can work quite well. Similarly, things like data loggers are great resources. If you can get that connected to a computer, to a PC, that can be used again with your screen reader and magnification software to allow you to access a whole range of different measurements. We get lots of different talking timers or large display timers. I've got a little one here that I'm just going to hold up to the screen, which is quite handy. And that can be set to count down. It can announce every second, every 10 seconds. And again, there are online options if you look about for that. So timing is something that the visually impaired learner can increasingly do fairly independently. We get talking or large display thermometers. Again, I've got another one here. This one here is a talking thermometer. If I just press the button. Speak to us.
24.1 degrees Celsius.
Okay, so that's a very useful device for sort of using in the science classroom. Switch that off. Okay, lots of other things that are very useful. I've got things like tactile rulers. Okay, you can see this one is a nice contrast, the yellow and the black. Centimetre marks clearly given. So if you look onto things like the RNIB website, you'll find lots of things like tactile rulers, measuring tapes and protractors that are very handy in science. Final screen here, we're looking at a few other possible bits of equipment that might be handy. When we're talking about lighting Bunsen burners, using the gas lighter is invariably easier than using a lighted splint. And walking around the classroom with that. So having a gas lighter to hand enables the visually impaired learner to move up the barrel of the Bunsen burner and find the point at which the gas is, to light. So that can be very handy. Been talking about using your colour sensors and your light detectors. If you're looking to maximise contrast, it's often useful to put a bit of white card or a light screen behind the object that you're looking at. Put on there bump-ons. Bump-ons are little plastic dots that you can use. They're very handy for marking buttons on electronic devices, just generally marking points. So bump-ons are a handy bit of kit to have around. The wiki sticks I've mentioned already for using in modelling. They can also be used to do a very quick graph or a very quick sort of model, and similarly things like plasticine are very handy. I quite regularly sort of knock together a quick red blood cell model out of plasticine, which is much more effective than using a sort of diagram to show that. Elastic bands, pins, enlarged and bold or embossed graph paper. I'm just going to very quickly hold up to the screen a bit of corkboard here. I'm going to have to put this in front of me. This bit of corkboard is showing you a tactile graph that you can do in science. What we're using there is embossed graph paper that can go into a Perkins Brailler. The visually impaired blind Braille user would then sort of be able to braille on their labels and then use pins to plot the points on their graphs. So that's a very handy way of doing graphs, sort of line graphs, in science to sort of look at their experimental results. For partially sighted pupils, you can obviously prepare enlarged graph paper very easily using sort of word processing packages now. A couple of last things there. Obviously, we've talked about trying to ensure that our visually impaired learner is as independent as possible in the classroom. So labelling is a big thing. You can get sort of Braille Dymo labellers with tape, and that can be very useful for putting onto chemical bottles or onto drawers or things like that. And similarly, you can get clear self-adhesive sheets of sticky braille that goes into a brailer, and you can get braille labels done that way to go onto bottles or whatever else you need to mark. Final screen here is just a whole load of references. I'm very aware that in what we've done today, we've kind of only really just touched on some of the adaptations and some of the difficulties, issues and strategies that are out there. So this set of references hopefully gives you a little bit more information. So thank you very much. Bye-bye now.